Hey everybody, Mr. Judson here. So let's see, there are still some things that we would normally cover in Chapter 7. However, my main focus right now really is just to try and get you guys your Central Washington credit. These items are items that we would normally do because they went with our hot air balloon project. But since that's gone, it seems like maybe this would be a good thing to cut out as well. So we're actually going to backtrack and go to Chapter 6. We had just started Chapter 6 when school was shut down. If you remember, we were talking about solving differentials. And so there's one particular type of problem we really need to get to in there. So we'll be doing something today that will seem pretty familiar to us. But that's the plan. Go back to Chapter 6. We got 2 sections there to cover on differentials. And then we'll move on to Chapter 8. All right, let's take a look. All right, so I haven't done this for a while. Let's go ahead and start with an entry task. So the first thing we want to remember about solving a differential is this idea of separation of variable, and then try and figure out what y is equal to. So let's just get the separation of variable part to begin with. You guys go ahead and try it. All right, so to separate these, I'm going to go ahead and factor out a y. So I have dy over dx is equal to y times x minus 1. And so now I want to get the y stuff over on the left-hand side, the x stuff on the right-hand side. So when I bring this y over, here we're multiplying. I got to do the opposite and divide. So I'm going to think of that as dy over y, which is equal to, here we're dividing by dx, so we'll move it over and multiply, x minus 1 dx. And what I'm going to do is I'm going to think of this as 1 over y times dy. So let me make that change. 1 over y dy. And now we want to integrate both sides. So we'll integrate this side, we'll integrate this side. And so, yeah, some time has gone by. We got to remember some things. What's the integral of 1 over y? Well, this is really a u prime over u, right? The derivative of y is 1 with respect to y. And so whenever we have a u prime over u, that becomes natural log absolute value of y, and on this side I've got x squared over 2 minus 1x plus some constant. We would have had a plus c over here as well, but we'll move it over and combine it with this one. So now the goal here is to solve this for y. And that means I want to be able to say y equals something over here on this side. And so to get y by itself, what we're going to do is something called exponentiating both sides. That's our big word for the day, exponentiate. What it means is we're going to make these exponents. And what you want to remember is the rules in algebra. What you do to one side of the equation, you have to do the same thing to this side as well. So what I'm going to do is I'm going to say, let's do e raised to the natural log absolute value of y equals, this will have to become an exponent as well, so I've got e raised to the x squared over 2 minus x plus c. And what I'm going to do right here is I'm just going to make a note to myself that y has to be greater than 0. And by doing that, that means I can get rid of these absolute value signs. See, what we're saying here is that the natural log of y, and then I'm going to do e raised to that, and so since those are inverse functions, they undo each other. And so I end up with just y equals on this side. And then over here, I've got this same thing, e raised to the x squared over 2 minus x plus c. But that's not the answer that we're going to see at the end. What our book is going to do is they're going to go a step farther, and they're going to say that this is really the same as e raised to the x squared over 2 minus x times e to the c. And the reason they do that, let's think back to algebra 3-4. When you multiply two bases that are the same, you add the exponents. And that's what we're doing here, is we're adding c. And since e really is just some number, 2.718, whatever, so I got a number raised to a constant, really this is just a constant. And so what I can do is I can say that that whole thing is equal to some constant times e raised to the x squared over 2 minus x. And there is the solution to that differential. So the two things that we'll see today are, one, having to factor this y value out, and our separation of variables. We've got to get the y stuff on one side, x stuff on the other. But then once we integrate this, we're going to have to find a way to get y by itself. And this is pretty common right here, that you end up with a natural log, and then you exponentiate both sides. And then also the idea of separating this into two things that are multiplied, where we know this all is just a constant, and we can put that out in front. And I'll give you guys a hint here. This really looks like the PERT formula. If we think about A equals PE to the RT, that's pretty close. The P is our constant, the E is this value right here, and our exponent, well, that's a little different, but it's kind of similar to the PERT formula. And we're going to see that come out in some of the things that we do here today. Let's try another one. All right, you guys go ahead and try this one. See if you can solve the differential. And remember, our goal is to get to a point where I can say y equals something. All right, so I think the first thing I want to do is I just want to call this really dy over dx equals 4y. Right? Because y prime is the same as dy over dx. And then I'll move the dx over here and multiply. I'm going to bring the y back over to this side. Since I'm dividing, I'll call that 1 over y dy. And that's equal to 4 dx. If there's a constant, we'll always leave it on the side with the dx. It just makes it a little bit easier. So this looks like the last problem. This will be the natural log absolute value of y plus some constant, but we'll add that to the other side. This will just be 4x plus c. And so now I need to exponentiate both sides. It just means these become the exponents. So e raised to the natural log absolute value of y equals e to the 4x plus c. I'm going to say right here, I'm just going to make sure that y is greater than 0. That way I don't have to worry about the absolute value signs. So you take the natural log of y, whatever that is, you then do e raised to that. It brings it right back to that number. And you can always check something like that on the calculator. Do the natural log of 4, whatever you get, then do e raised to that power, and you should come right back to 4. All right, over here I've got e raised to the 4x times e raised to the c power. And now I know this is just a constant that I'm multiplying times this. So y equals that constant times e raised to the 4x. There is my solution to the differential. All right, you guys go ahead and solve this one. All right, Alright, so we know this means the same thing as dy over dx equals 2x over y. I want all the y stuff on the left, the x stuff on the right. So that means I'm going to have, let's see, this time if I bring the y over, I'm dividing here, so I have to multiply. So I've got y times dy. That equals 2x times dx. And now we need to integrate both sides. All right, so this will be y squared over 2 plus some constant. You can go ahead and write that in here if you want. And that's going to equal 2x squared over 2. The 2's will cancel, so I get just x squared plus some other constant. Now, I don't know that these are the same. They could be different. But once I move this over and subtract it, whatever this constant is minus that, I end up with just a constant on this side. So that's usually why we don't write that down. Alright, so I'm not going to exponentiate this time because to get y by itself I just have to multiply the other side by 2 and then take the square root. So y squared is going to equal, if I multiply this by 2 I get 2x squared. If I multiply this by 2 I just get some other constant that I still don't know. And now I just need to take the square root. Y equals the square root of 2x squared plus c. And since I'm solving for a variable, I want to make sure I include the plus or minus in there. So it could be either one of those. There's my solution to that differential. All right. So this one's a little different, and really this is the direction we want to go with solving differentials. It says here that the rate of change of y is proportional to the value of y. Or I could say the rate of change of y is proportional to itself. That could be worded either way. And so what we have to do is we have to write the differential and then solve it. And so when you look at this, you'd say, okay, the rate of change of y. Y is what's changing. And it's changing with respect to time. So I'm going to say dy over dt is, that's an equal sign, proportional. So last year in pre-calc, we did some direct variations and we said that, y varies directly with x. When we did that, we would say y equals k times x. Or if y is proportional to x, y equals k times x. It's kind of like similar triangles. When things are proportional, you're just multiplying them by some number. So the rate of change of y is proportional to the value of y. So k times y. These words mean the same thing as this right here. Now we want to solve that differential. K is just a number. Y is a variable. I want to get that over here with the dy. And on this side, when I move that dt over, we're going to integrate with respect to time. All right, you guys go ahead and try that. All right, so I'm going to bring this y over and divide, so I've got 1 over y dy is equal to k times dt. And now I want to integrate both of these. So we've already done a problem like this. We know that's going to be natural log absolute value of y. And over here, we're integrating with respect to t. K is just some number. And so like if this was a 3, I would say, okay, well the integral is just 3t. Well, now it's going to be kt plus some constant. And so now we have to solve for y. So I'll exponentiate both sides. I've got e raised to the natural log absolute value of y equals e raised to the kt plus c. And we're just going to say here, let's let y be greater than 0, because that way I don't have to worry about how do you solve for an absolute value. So this will now be y equals e to the kt times e to the c power. Remember, when you multiply these, you add the exponents, which is what we're doing right here. So we would just say that's the same as y equals c times e to the kt. So remember a little while ago I said it's really close to the PERT formula? Well, I don't think you can get any closer than this. If I say p times e to the rt, that's as close to the PERT formula as you get. So when we say the rate of change of y is proportional to the value of y, or proportional to itself, what we need to know is that we should end up with something that looks like a PERT formula. It doesn't mean I can go from here straight to here. I still have to do all this work. I have to show how we're getting to that formula, but at least I know what I'm working towards, which is kind of nice. Okay, this right here would be my answer to this differential, and I look at that and I think, boy, that looks a lot like the PERT formula. So what if they said something like this? The rate of change of y is inversely proportional to itself. How would I write this out? You guys see if you can write the differential. All right, so here's another one. The rate of change of y with respect to x is inversely proportional to x. So the first thing we have to do is we have to write our differential. Well, this part isn't hard. The rate of change of y with respect to x, that's just dy over dx. What are we going to write for inversely proportional to x? So what we learned last year is with an inverse proportion, that's when you're dividing by some value. So this is going to equal k over x, and that's what we want to try and solve for. So let's see, if I look at that, there is no y value, so I've got nothing to bring to this side. I'll just bring the dx over. So dy is going to equal k over x dx. I want to integrate both sides. So the integral of this would just be y. It's kind of nice when that happens because I've got y by itself. That's what we're trying to get to. Here I'll bring this k to the outside because again it's just a number. K times the integral of 1 over x dx. And now since that's a u prime over u, we know that the answer to that is the natural log of x, absolute value of x. So y equals k times the natural log, absolute value of x, plus c. Now really k should be multiplied times everything that this becomes, so I should have that in parentheses. But once I multiply that out, k natural log absolute value of x, k times c, that's just one constant times another, still just a constant. And there's my answer to that differential. All right, that's what we have for today. So here's our assignment. We're on, I believe, number C7. We're going to do page 418, 1 through 10, 12 and 13. Remember, we're going back to chapter 6. All right, there it is. You guys have a good day. Stay safe. See you on Thursday.